All right. Hello, everyone. Let me shuffle a few more windows here, and then I think we're ready to go. Oops, I hear myself. I have to figure out where that's coming from. Hmm. Not what that was. Okay. Seems good now. Yeah, this is okay. Chat. Let me pull the chat back. All right. Here we go. Quick introduction. I should probably do before we jump in, although you can see maybe sneak preview of what I am going to be working on today. But hello to everyone. Good morning, or whatever time of day it is where you're at. My name is Tim. Go by foamyguy on GitHub and Discord. And we're going to be working on some CircuitPython projects today. We're getting back into display IO land, which is definitely somewhere I like to hang out a lot. If you don't know, though, what CircuitPython is, quick introduction to that. You can go to circuitpython.org to learn more. This is basically a version of Python that can run on these tiny computers called microcontrollers, and you can write your Python code. You save it into a file called code.py, like I have one loaded up right here. This just shows up like a thumb drive would on your computer, just like if you plugged in a thumb drive or an SD card or something like that. Edit this file, you save it, and the microcontroller will run the new code for you. So I will be today working on mostly this PyPortal, but these do come in all different shapes and sizes. There's a mag tag. This one has an e-ink screen instead of a regular screen. The PyPortal is nice because it does have a regular, I guess TFT maybe is the technology for the screen. It also has a touch overlay, so you can do some stuff with that. So tons of different shapes and sizes for these little microcontroller computers, but we will be focused on ones with screens today. If you're interested in this project, you want to help out, you can click on the contributing link up here. This is going to list all the open pull requests and all the open issues, which you can always get started by looking at the pull request, trying it out if you have the hardware, leaving a comment if it worked for you, or if you had trouble, or if you think there's anything that needs to change, or if you think it looks good. You can kind of leave comments along those lines on the pull request, and that's a good way for folks to start getting involved in the project. You can also try to tackle the open issues, a bunch of which right now still are the typing annotations. We're slowly whittling that away. Definitely thanks again. I know I've mentioned it before, but huge thanks to Tektrick, who has been... Tektrick has really knocked out a lot of the typing stuff, and they're still working on it. He's still working on it, so huge thanks to them. So that's what you can do if you're interested in actually getting involved with the project. But of course, you can also just hang out with us on Discord. The link is down there on the stream. The chat that's on the window, I believe it should be on the window, right? Yeah, the chat that's on the window there is on the Adafruit Discord in the live broadcast chat, which I will also mention the Adafruit Discord there, but also adafruit.com if you head here. This is the company based out of New York. They're a hardware and software company. They are the ones who are providing the primary financial backing for CircuitPython. They're paying the folks that work on the CircuitPython project, including myself. And so if you head here, you can buy all sorts of hardware to use with CircuitPython and other things. And that is helping support the project as well, again, since they're paying myself and the other folks who are working on the project. So huge thanks to anyone who wants to buy their hardware from adafruit.com. So I will jump right in a little bit. Let's set the stage for what we're doing and then just kind of get going. So Lady Ada emailed me with this idea. This is not a thing I had heard of before, but it definitely seems cute. This Nico Cat cursor chasing program. So this is an old program on, Lady Ada mentioned she had it on a Mac. Looks like maybe it supported lots of other places as well, and it's been ported to many different platforms over the years. But it was originally this little, sprite sheet cat image that will animate itself and follow the mouse around, and then maybe go to the edge of the screen, and there's a little scratch animation that it can do. So we are trying to make a display IO version of this, which should actually be, I think, pretty straightforward, because display IO gives us tile grid, and tile grid is kind of the perfect tool for making these little sprite sheet animations. So I have downloaded the file, I think. We'll grab it again. Not this folder. Let's see here. Yeah, I have this file. Right now it's PNG, so we need to make it a bitmap. I'm just going to use GIMP to do that. And let's take a look at what we have. So there's some footprints, paw prints, I guess I should say. There's a couple small things, a fly. Inverted color below it. This looks like a mouse. So we basically have a sprite sheet with all of these little animations. One thing is there is looks like probably a pixel in between these. Yeah. Which I don't think we need. And I'm not sure if tile grid has a way to work around. Let's take a look. Hey, thanks for the note on the audio there, Dexter. Driving the feather sense today. Nice, nice. Playing with the is it you that mentioned playing with the gesture sensor? Trying to make an interface with that. Maybe I'm thinking of might have been C Grover. Gesture sensor that we were working on that last week, I think. Let me pull up the docs for tile grid. I think, I don't know if it supports a padding pixel in between. This is not really the docs though, right? This is a learn guide. We want docs. Right, apparently there's more tile grids out there. Let's try that. That's what we want. So what do we pass in? The bitmap, the color palette, width and height, the tile width and height of the tile, the default tile, X and Y. Yeah, there's no like padding. Maybe at some point we could implement that. I guess it would be a enhancement in the core, I think, right? So I think for now though, we need to collapse this. We need to get rid of the extra pixels. Make it gesture activated. Nice. Dice thrower. That sounds cool. Which GIMP might not actually be the easiest tool for this. I think there's like I had a texture pack. Okay, really, we want a texture unpacker. Do this too. I recently did something. Don't know exactly. Let's see. Oh, I'm gonna. Let's see if we can find like a sprite sheet editor. Nice to just like dump it in and. Nice to just dump it in and like cut it apart. Sprite sheet separator? Well, we don't really need to cut it apart, I guess, but we need to take the pixel of padding out. Scale. Add margin? Margin or padding? Or remove grid lines. Sounds relevant. What do we have? GIMP plugin. Or the other option is we leave the lines and they are part of the tiles. Well, they're gonna get converted. Let's look at some sizes here. They're gonna get converted to visible. 32 by 32 is our sprites. So we could instead just use 33 by 33. And we'll fill it in with an invisible color. Everything then is shifted by 1 pixel, sort of. Because we'll be placing it relative to the top left. Probably not so bad, though. Yeah, it's not so bad. Let's try it like that, I think. So we need to go colors, no, mode, image mode. Oh, we are already indexed, okay. What I'll do is just make a new layer. And I'm just gonna put this blue in it. I think we're just gonna use this blue as transparent. Although really having our tiles be 32 by 32 is nice, because then it's probably closer to being around multiple of the screen. Anymore, this is like 8 years old, I guess. Years old. Gotta put it in the plugins folder. Probably a good chance this doesn't work still with modern GIMP. I don't know. Program to do it. Probably just do it, I guess, right? I would have just been copy pasting the time I was looking for a way to automate it. We'd probably be done already. Oh well. We don't really need any of the, I want to make a new one? Yeah, maybe I'll make a new one. Size would it be? Basically minus 1, 2, 3, 5, 6, 7, 5, minus 7, 53, that's going to be 256. 192, 256 and 192. Maybe it's going to be better to have it the same size, though, to start with, so that we can collapse both directions. Right? Okay, we're on this layer. I'm sure there is a tool that can do this more automated fashion, but will it clamp to only the size of this? Yeah. I'll line up all of the columns, and then I'll grab the rows and scooch those all up by one as well. Yeah, flood fill. I thought about that for a minute. You probably said that before I did it. Sorry, I didn't look at the chat for a minute. I thought about that. I think I want to keep the 32 by 32 size tiles. I think they would bump up to 33 by 33. It would be nice. Maybe I'll make an issue, like a long-term issue on the core. It would be nice to implement just like an extra argument on the constructor for padding, and then it can skip. I do know lots of engines, sprite sheet engines and stuff support having this extra line of padding in here. All right, a couple more. A little quicker. Oh. Fixed it. Yeah, it was move. Be in the right mode. Have to flatten it too. Try to do the rows. Oh, right, the kitty falls asleep sometimes too. The one thing we'll have to do is map this sprite sheet to the actions that the cat's doing. I think I'm going to make a class. I think I'm going to make a class for this, a kitty animation class. I'll vaguely try to keep it sort of general, but realistically it'll probably take another pass to generalize it better. I think it'd be nice if we just had like a display IO sprite animation class. It's pretty easy to do, but it'd also be nice if there was just a helper class. You set it up, you call animate, and you don't worry about specifics. I think that'd be cool. But I won't necessarily aim for all the way generic from scratch here. I think I'll make this one, try to make a loose framework that could be made more general, and ultimately go back and really polish it up. Where is flatten? Isn't there flatten? Merge down, I guess. Let's merge down everything. Flatten, there we go. Okay. Like, I swear this exists. Okay, and we got white. We don't really want white though, truthfully, actually. Let me undo that. Why did we get white? That's interesting. So just use a different color for now. Background. If I flatten it now, not get all the extra white? Yeah, okay. Now we can grab rows. And can I just do this? Nope. Not though, that would be convenient. So I guess we go cut. Flatten it again. Careful to make sure I cut out of the right layer. And do I need the bottom row? We could probably get away without the bottom row. Where did the below it? Not sure what that means. Wonder. I don't know if we did that right. Right. No, we didn't. Okay. But paste. I guess I'll keep it. I guess we want to use the fly. The problem is the fly is a different size. Mouse 2. I don't know if tile grid supports differently sized tiles. I don't think so. We'd have to remove the text, definitely, if we wanted to use those. Guess let's go ahead and do that. And then I guess one question is, do we want... Oh, okay, we're back to having some white in the background, which we don't want still. Oh, what? What is it? What? Okay. Going on here? Okay, one problem we have is this has got a layer on it. Not really ideal. Okay, flatten again. Got this. Copy. Alright. Now we have 32 by 32 no paddings. And we can, are we still in? No. Mode, indexed. We want to keep green and blue? Should I just fill everything in blue? Probably just go ahead and fill everything blue. Need an eyedropper. Oh. Okay. Now go to index app. We're going to put blue as 0 so that we can call make transparent 0. And it will get rid of the background. I think save this. As a GIMP file, but then also export it as BMP. Yep. All right, so we should have now here. And let's see, what is a good... I guess I could just start from scratch, maybe. I was trying to think what's a good example to start from, but it's rare that I start from scratch. Let's go ahead and do that. So we do need display board. We're going to want display equals board display. We're gonna want a tile grid. We're gonna want image load. Image load? Load. I guess that's what I'll start from, is the image load. Or maybe the learn guide tile grid. I'm gonna make a group, main group. Group. All right. I think let's let's just draw it to start with, and then I'm gonna do that. No, let's make the class. Let's make a class for it. Eventually this will, I could move it to another file. This is gonna extend tile grid. Or group? Should it be group? No, I think tile grid's fine. We're just gonna, we're gonna pass through? No, we're gonna have different stuff. User need to pass anything to us? Not really. I don't know. I don't know for sure the right syntax of this. This might be wrong. Knit. So we are going to have to call these things. Yeah, I think let's pull up. That'll work. Oh, we do need to load it actually though. This, yeah, let's do this. Oh, so the thing is though, oh, we need some of this, I guess. Eco, cat, animation, no, cat sprite sheet. And this is going to be this, right? We want it to be on super, this wrong. Don't do this. Right is going to be self. Why are these mad? Oh. Okay. So we are now a tile grid. We're gonna have def up animate or update. What does LED animation call it? I feel like we're basically like the end goal will be to have something like LED animation that can maybe be display IO animation standard. Okay, so this calls animate. Yeah, def animate. So it will be the user code's job to call this once, or however many times they want, I guess, inside the main loop. And this class is gonna have some more things like it's gonna have a bunch of states. Let me think here. I think it's going to have states for each of the directions it can move, which there are up, down, left, right, and then also the 4 diagonals. These 2 are moving down. These 2 are moving down right angle. These 2 are moving right. These 2 are moving up right angle. These 2 are moving up, up left, left, down left, down. And then we have 2 for scratching the right wall, 2 for scratching the top wall, 2 for scratching the left wall, and then these 2 here actually are 2 scratching the bottom wall. We already had our moving down here. Okay. Moving left. I guess really just sitting still should probably be 0. The numbers are kind of arbitrary, but actually I'm just gonna have state sitting 0. And these are not necessarily meant to match up with the indexes of these. Although it will help us get matched up to the indexes of these ultimately. It is a coincidence though that 0 does happen to be 0 here. Oh, do I have? Yeah, I guess I do have that many. Up, right, down. Oops. Okay. So yeah, 4 directions and 4 diagonals. We also have these. Should have duplicated. So we're basically going to have states for each state that the cat can be in, and then inside of animate we'll check the current state, and the current state will have a list of sprites that it will animate through. I think that work out. Eventually we'll add sleeping. There's like a sleeping, but let's get these ones working and then it should be easy to extend. There's like gets tired. Oh, it looks like maybe scratching its face as well. Gets tired and yawns and then sleeps. And then I guess probably wakes up. I don't know, this one is like excited cat. So we'll add some more once we get everything going. Let's start with these. Current state. Sitting. just start on sitting. And let's just say okay, we're gonna do this, then how do we set the tile grids? So width and height, okay, these are 32. 32. We do want 1 by 1. How do we set the index? Is it dot index or dot value? Source index? Oh, well, we would do it right. We set it with square brackets. And you can either do X, Y, or just index. And we only have 1. So I think we'll just do this. I'm just gonna hard code it. Eventually, I don't know, maybe we'll make more constants for a dictionary that maps to constants is probably more efficient. Maps to the indexes in the sprite sheet. Let's see if we make this work though. So if we're sitting, we just always set it to 0. Doesn't matter. We don't have a list to work through. Sitting is static. We do need to go palette, make transparent. 0. Should we keep the palette? Do anything else with the palette? Sprite sheet. Should we keep sprite sheet? Do anything with that? I guess not. So yeah, let's try this. Group, this is wrong. We need these. Nico equals new one of these. And this, no, main group dot append Nico and show display show main group. Okay. That should get us somewhere, maybe. It'll either crash or show something. So that might hit our padding strong, which is not good. 33. So basically this means image is not divisible by 32. 6 by 193. I messed up 1 vertical pixel. How do we find it easily? That one looks good. One looks good. I think my guess is, I mean, these two? I don't know for sure if I'll use these footprints. Maybe we could find a video of it running. I'm not exactly sure how if the footprints would be like behind it or in front of it or what. Okay, so let's go cut. Why did that not cut? Hmm. Up by one. And shuffle this up by one also. Hmm. Alright, now redo some of this stuff. Merge, no, let's just flatten. I'm gonna save the updated copy as a GIMP file in case we need to edit the source. I'm gonna export again as a BMP. And actually, honestly, I think I'm gonna step away for 1 minute and make a coffee. Sounds pretty darn good. Export, yes. Oh, I didn't save I didn't, this image canvas. That will not cut it for the 1 pixel I'm trying to. Now we're gonna export this again. And save it once again. And there we go. Got the cat. So that's a good sign. Good stopping place. Buy followers. No, I don't want to buy followers. Thank you. And didn't really say thank you. I guess I don't really appreciate that offer, but oh well. All right, yeah, I'm gonna make a coffee real fast and then come right back and keep going. All right. Some cold brew going now. Got our cat sitting. Got some gloves as well because my hands were cold. And now we're jumping back in. Heck yeah. Let's see, where is that one? Beans, I think. Maybe we can, let's take a very brief detour. Let's see if we can find Nico Cat Mouse follower. YouTube. Let's see if we can find Games Mouse Cursor. Cat Games. Oh, no, this is a video of Mouse Cursor for you to put on a tablet for your cat to play with. Macintosh? Which I don't know how to spell. So there was this. Which follows the mouse. But this one doesn't seem to use the paw prints. Would be interesting. I guess we could spawn paw prints like behind the cat. Close that for now, but I'll leave this open. Doesn't seem like it's going to be easy to find an actual, gosh, YouTube thumbnails are crazy, huh? Okay, doesn't seem like it's going to be easy to find video of what it looks like. This one doesn't have either. It shows this, and it shows part of the falling asleep and waking up. Let's show the like a video of it or anything. This was actually originally on this PC 980. Okay, let's dive back in though. So we got it to show our single sprite. Let's work on a movement mode. So let's say here, go back to this. Let's say inside animate L if we're gonna copy all of this. Actually, we're gonna copy just this. Moving. Let's do right first. So this is where it gets interesting. We're gonna want a couple more things. Maybe we should have self dot animation time. I don't know if I like that name. This is going to be the amount of seconds between changing sprites. And we're going to start with half a second. And I'm making it self dot. Eventually we'll make a property for it also maybe. So maybe I should do this, or we'll do that at the time. Can you generate the property? Can I do like code generate? No. So like in Java code, you can do just like generate getters and setters, which is basically what properties are, right? I don't seem to have implement methods. That didn't do anything. Okay. So we'll just go ahead and make it property def animation time. We might rename this, I don't know. So this one return self this. You can make a setter, animation time setter def. We'll probably accept this here as well. But just default it to that for now. And we will need last animation time. I'm going to start on -1 so that we need to know that we haven't started yet. We could check for that. I don't know if we'll actually need it, but okay. And now inside animate, we're going to say we need time. Whoops. Time. So now we're going to limit this. We're only going to animate after animation time has elapsed. So a bunch of the times when we call this, nothing will happen. If we should make a now. Now. If now is greater than self.last animation time plus self.animation time. But we can use the property. Okay. If the last time we ran plus the amount of time we want to wait in between each time, if now is greater than those two things added together, then we know it's time to go again. So that's when we do this. And in here, we're going to need to be setting one of the things. I think we should have current sprite index. I'm going to start on 0, but maybe that should be... Nope. Okay. And I think I'm gonna represent the different state animations, because basically each state is gonna have its own animation. And I think I'm gonna represent each of those animations as just a tuple. So like animation moving left. Oh, we're starting with right though. Right is a tuple. And it contains the indexes of the things we need here. 0, 1, 2, 3, 4, 5, 6, 7. So 8 starts here, moving right. So moving right are these. So we're basically going 8, 9, 10, 11, 12, and 13. This tuple is going to have 12 and 13, and it's just going to alter between those two. I'm going to call this current. I'm going to call this current animation index. Because it's not. It's not going to be the index within the sprite. Those are going to come out of here. It's going to be the index within this tuple. And we're going to have a method advance animation index. Should this be private? I think you're really not meant to call this from outside. This is gonna do self dot this plus equals 1, and then if it's too big, greater than we also need current animation. Current animation to this. I guess we should have one for sitting, even though it's only one. Maybe this should work the same. So maybe we don't really need. Yeah, I don't think we'll really need this big if statement. We just, let me comment it for now though. Maybe if I'm wrong, then maybe we'll want to keep it, get some code out of it, but I'll delete it if we don't. So if it's time to animate, we are gonna, well, let's finish this part. If the current animation index is greater than the length, greater than or equal to the length of the current animation, then put it back to 0. Yeah. We always go up by 1 until we get too big, then we put it back to 0. So here we're gonna do what? We're gonna say we are gonna get the current, so this we're gonna set equal to self.current animation, and then within that tuple we're looking up self.current animation index, which is going to give us back sprite index inside the sprite sheet, which we are then setting to the tile grid. And then we would just go self advance so that next time we're on the next index. And on this one, it will start on 0. It will go up to 1. 1 will be too big, and it will go back to 0. So it'll just always be on 0. So now our animate function doesn't care which animation we're actually running. It's all just driven by the data, which are going to be these tuples. See how this is like, we're a little bit's hard-coded, like, you know, these states are all hard-coded and stuff in here, but trying to keep it to where the functions are not too tied to the logic of the cat, and then later on we'll be able to generify some of this part of it, and then hopefully make this into like a generic tile grid animator that folks could use for games or anything else that you want simple sprite-based animations on. Maybe like exploding explosions in a game for bullets or something is one place where it comes in. Animate. So one thing is we're not going to be sitting anymore, are we? It's going to automatically... I guess we have two concepts here, don't we? We have current animation, which is matched up with a current state. Maybe we should not... Maybe the state should be... Maybe those should be tied together instead of separate variables. Yeah, I don't know if the cat's gonna be sitting or if it's gonna already start animating. I guess one problem is we're not calling animate in here. Eco.animate, this is what we would need to do. Oh, you know, one thing we're also not doing is setting these things. So, this last right here, now, yeah. Let's give it a try. The worst that happens. Ah, okay, yeah. That is a cat that looks like it's running to the right. It's a little slow. I think we could run faster than that, and it would look nice still. So let's try 3. See what 3 looks like. Didn't hard code this anywhere else, did I? Doesn't look like it. Okay, save that. Ah, yeah, that looks nice. Oh. It got a little jumpy once. I'm guessing it probably collided with garbage collecting and made it look a little weird, but I think that looks nice. That looks like a cat that's running to me. Of course, the other thing that we'll do is change the position. Right now, it's only animating through the sprites. It's never changing the X or Y. I think that looks pretty good. So do we want to work on the rest, or I should say more, of the animations? Or do we want to work on moving the X and Y of the cat so that it's, when it's running to the right with the animation, it's also actually physically moving to the right? I think I want to start that as well. I think I want to get that started, and then once that's working, go back and do the other animations. So I think we're going to have def move. How is this going to work? This one might need the... This one might need the if statement. If the state is this, then change the XY like this. Maybe animation time. Maybe this should have been animation speed, although then it's a little misleading because speed sounds like if you raised it, it would get faster, when the case is actually the opposite. You would need to lower it to get faster. Movement time. So this is going to be how long to wait between moving the position tile grid. Let's see what it looks like when it's the same. I don't know if that's what we'll want ultimately, which is why I'm making a separate thing for it. We're gonna have a couple of these as well. Oops. There we go. I should also mention, I guess, while I'm just kind of working on this here. Definitely, though, huge congrats to Scott for obviously what he mentioned yesterday on his stream. Getting ready to have a child with his partner, which is amazing news. I definitely wish all the best to Scott. He's got a busy 2022 in store. I can only imagine. He did mention stopping the deep dives. And I'm not necessarily ready to commit to exactly what my plan will be, but I will say I will plan on doing something on Friday nights in that slot. I may take it over and do it like the same time, like 4, and this is my time zone. He always mentions it in Pacific, right? Because he's in Seattle, I think, or Washington at least. So his time zone, I think he starts at 2 p.m., but it's on at 4 p.m. my time zone, so I always think of it as starting at 4. Maybe I will start at the same time, 4. I'll have to work that out with my employer. Maybe I'll start earlier those days or something, because ordinarily I wouldn't get off technically really until 5, so I don't know. Yeah, I don't know. Maybe we'll work out a deal and I'll start at 4. Maybe I'll start at 5 and do it. Maybe we'll look into changing the day to Monday, because I have Mondays off to work on, like from my regular work to work on CircuitPython. So Monday is kind of my CircuitPython day. I plan to stream, to some extent Mondays anyway while I'm working. So maybe Deep Dive would move to Monday. I don't know exactly. There's a couple ideas, a couple of different ways it could go, but I will say that I do plan to do something in the absence of Deep Dive. I plan to do some streaming while Scott is away, anytime that I'm available at least. So we'll probably be picking up, and I think I will probably keep these Saturday mornings too. I kind of like the Saturday morning streams, so maybe we'll be a lot more regularly doing 2 streams a week, although I'm probably going to be doing that on Mondays anyway. Yeah, I don't know the exact details yet, but I do plan to do something while Deep Dive is on hiatus, essentially. I think in here we're going to have kind of the same type of logic as this. But this would be, we could have we'll need a last move time as well. In case these are different. Right now they're going to end up being the same because they're both set to the same delay, 0.3 seconds, but eventually we might want them different, so I'm kind of keeping everything separate still. Time. Now this is where we would have like if self.current state is state self.state moving right, then we're gonna go self.x because we're still extending a tile grid, so we should be able to just move x. +1, I'm gonna say +1, but you're gonna want some clamping behavior as well. Should it be up to the sprite to stay on the screen? I don't know. This is something that may eventually get factored out of this class, because in the more generic case, maybe you wouldn't always want to do it. But I think for now I'm going to put this logic to clamp it to the display here, which means I actually need the display. Or the width and height of the display at least. Yeah, I think I agree ultimately. But I am also not necessarily aiming for the general case right out of the gate. I think it's going to be... This one will be kind of specific to the cat, but it will be a good starting point to make a more general one. It'd also be relatively easy to just throw like a clamping, you know, true false or something like that, just a high level switch. Turn it on and off. So if they don't pass the display size, we're going to try to get it from board. If display in your board, then self display size will be a tuple, and it's going to be board display width, board display height. Else, I don't know. Else it would still be none, and then this logic would not work. So maybe that's how you turn it off, is by... Well, I don't know. Right now it's dependent on the display. I don't know. Somehow we'll figure out a convenient way to turn it on and off. For now, though, in my case, it's always going to use this. But if we did get past the display, then we just use it. So we just say this equals the one that passed. I'll probably just go with this default case. Should work out for me, I think. Get the roller going when the oh, you got the roller going when the proximity sensor detects something. Nice. Next challenge, wake word. That's pretty cool. Wake word on the it does have a little microphone on there. That'd be pretty sweet. All right, what do we do here? So I think we're gonna have also, we have animate and we have move. Oh, right, we are here. So this was our clamping. If and we need to account for the size, which we can fetch from the tile grid now because I added it to the core. Amazing. We get to use my new core thing. We want to basically say if the current x plus 1 plus tile width. Ooh, did I not add it to, oh, I think I just don't, I would have to update my stubs. The current x plus 1 plus the tile width is greater than or equal to the display size 0, which would be x. No, but really what we want is actually if it is less than this, then we want to do this. which is increment the x. If it's less than the display size, then we increment the x. This is Java if okay, so I think that should stop it moving at the edge. And I think we should have def update. So like realistically, we might just get rid of move altogether, right? The generic animation, like the generic sprite animation, probably doesn't need move, right? So realistically, my Nico cat would probably extend the more generic animation and it would add move and update and stuff to it. I think I'm going to keep it one layer for the project. But like ultimately, when the animation works how I'm kind of envisioning, that would probably be the way, which then removes move and the whole idea of display clamping off of the plate of the animation class altogether. But I do want an update, and then basically an update, we're just going to call animate and move. And then in here, we're actually just going to call update instead of animate. So we call one thing, it does both the animation and the movement. What is this map? So that should move it to the right, I think. It's been a minute since we ran it. Let's give it a shot here. So I think the problem actually is that we're still in sitting. Even though our current animation is moving right. Yeah, so really this would be more proper. Oh. So the problem here now is, you know, we could cheat by, oh, well, it just doesn't know this is a tuple. That's right. Okay, so I think this would work now, actually. Yeah, okay. So it was treating this as an int. Just 0 with parentheses is actually still a number, right? It's like as if you were going to do math inside the parentheses, but you didn't. So it's still a number, so you can't subscript a number. But by adding this, we tell it that it's a tuple for sure. And now it can subscript it. And now we no longer are animating, which makes sense because we have set our animation to sitting. So why don't we like wait, maybe like here, time.sleep, I don't know. For now, let's just do 1. Well, so the thing is we wouldn't be calling update. I guess that's fine though, right? Because this one doesn't have an actual animation. And then Nico current state equals Nico state moving right. Yeah. So we need a property for setting the state, actually, because we want to modify both the state and the animation. So we should actually probably have this and make property in a setter for I'm gonna still call it current state. I mean, it's current's kind of implied, I guess, right? But oh, you know what? I probably didn't change this when I copied it. Yeah, I sure didn't. Okay. So get the current state, new state, current state equals new state, New state. And here's where it gets tricky though. How do we also set the animation equals? This is where I think it might actually be better if the state was tied together with the animation list, basically. So I think I want to do this. I think I want to go actually going to take state this. And now this is going to be actually a tuple where index 0 is the ID, index 1 is the animation list, which is this. Nice, dice roller. Check it out. Do you have a, are you going with lights or, yeah, fancy LED, must be LED lights, pixels. Oh, you do have a display too though. So you have, I guess, probably I2C display 128 by 64. It's like the Featherwing, one of the TFT Featherwings. Oh, you got a tile grid for faces too of your dice. Nice. By 1. Oh, does it roll? It rolls. Does it roll 2 dice? Yeah. Rolls 2 dice. Okay, that makes sense. Neat. I like it. Monochrome melody. Gotta update your copyright year. I just noticed that on something I did the other day as well. I copy pasted a header, and then was like, oh, it's not right anymore. So we actually are not going to need these things. And we'll have to do this after we set all these up. And it will basically be state sitting animation list. And this actually needs to be state sitting ID. There we are. Okay. So we'll need to basically just declare the rest of these, but we only have 2 done so far. So this is why it's good that we kind of started doing the different features before we really finished loading all the different animation sequences and everything, because this actually changed. And actually, this is not the one for left. This is the one for right. They're all going to be tuples. This is just an empty tuple for now, I guess. I don't know. Well, let's fill it in. I guess we could do that. Moving left. Those are going to be just 8 higher than these ones, I think. This was 12, 13, 14, 15, 16, 17, 18, 19. Yep, 20 and 21. 20 and 21. Well, moving left filled in as well. So now when we change states, We will also that's the ID. Hmm. Do we want this to be the ID or do we want this to be the actual Here's the next problem is we basically well, okay, so the user would pass like state moving right. Okay. So in here we would say self.current state equals to new state ID and current animation is new state animation list. It's these. Sir, can I make these? No, self implies that they would be different for different instances, kind of, but they're definitely constants. Setting the current state to a new state will update the ID in the current state variable, which I guess probably should have ID in its name now, but it doesn't. Current animation will get set to the animation list from the state, which is now a tuple that has the animation second. So after, so yeah, here we would say current state equals state moving right. I would call update. Crashed. Get Tio. Let's see what that said. Change it to underscore current current state. But okay, that was the only one actually that needed to be changed. Ah, okay. So we sat still for 1 second and then we moved to moving right, but it does not seem like our X is updating. Updates calling move. Let's put in here print moving right. Not getting to here. Print. Right. So this is needs to compare to the ID now. Well, is not callable. Are we trying to call it? Oh. Yeah, we sure are, aren't we? Oh, okay, so that worked, and the clamp works, but it's way too fast. Like, mega way too fast. Doesn't seem like it should be that fast, right? Shouldn't this should be 3 pixels per second? And there's 320 total pixels, but minus 32 at the end that we can't use technically. 33 maybe? But that's still 290-ish pixels divided by 3. That should still be like 100 seconds or something, right? Why was that so fast? So the logic is wrong. We're not updating the time? We're not updating the time. Indeed, we are not updating the time. So in here, we need to say self.lastMoveTime. Last move time is now. So it was not waiting 0.3 seconds to move. Instead, it was moving every single step, the main loop, every iteration. Yeah. Okay, yeah. And now this is too slow. Way too slow. Truthfully. So we went... Once it's actually working, once it's doing what it's supposed to be doing, it's actually way further in the other direction. So let's try this. Or the other thing that maybe would make sense is, could it move when it animates? Like it's taking a step? Oh, nice. Got some hand-drawn dice. I like it. Yeah, I think it would look more natural. Actually kind of a bummer, I guess, because we're going to throw away a bunch of the logic we just made, I think. But I think we should just... This is also further coupling the movement with the animation, which is, again, the opposite of the direction we want to go ultimately with this class, because I do want to make a more general one. But I think we should move a certain amount of pixels whenever we animate. That way, it's like taking steps as it moves its legs. So... Do I want to make... outer if statement? Or do we want to add, like... Could make like a movement step here. So when it's moving right, it's gonna go, let's say, up 3 pixels. Let's start with 3 pixels, and it's not going to move at all in the Y. So this represents the X and Y data for each step. We're going to move up by 3x and 0 by y for each step while we're moving right. And so now here inside animate, we're going to go we're going to have to do this differently. If, oh, that gets really hairy with the left edge of the screen versus the right edge of the screen. So I think I can do these, right? If 0 is less than So actually, I think we should not set this to the ID. This should be the actual state. Let's kind of wreck the property setter for current state though. I don't know. No, shouldn't break the setter, right? This shouldn't break the setter. So set this equal to the whole tuple, and then this current animation can actually be current state animation list. This is movement step 2. Okay, this will actually be the full state. Basically getting rid of this. Okay, so if 0 is less than the current x plus the amount that we want to move, which is current state movement step 0, because that's a tuple with 2 things. And if that also has to be less than or equal to, no, just less than display size 0 minus tile width. So we're checking the step that we would take, and we're making sure that it's both greater than 0 and less than the width of the display minus the width of the ourself, the tile sprite, which is 32 in this case. If both of those things are true, then we're allowed to take the step. So self.x equals the new value, which we get, well, it's actually plus equals this. And then we just need to do the same thing for y. This is now 1. This is 1, and this is tile height, even though they're the same. For me, it might be different for somebody else. Once we do generalize this, we are now setting y okay. I think that's the right logic. It's tough to say, really. I think we're just going to give it a try. So every time it animates, it should basically move by 3 towards the right. I think it's doing it, but it would be easier to tell if it were taking bigger steps. Let's try 10. Yeah. I like that. I like that. It moves at the same time it animates. Once we hit the edge, the clamping, this is still working, so that's nice. And when it moves while it's animating, it makes it look like it's actually taking a step. I like that effect better than what we had before, which was just smooth movement uncoupled from the animation. We should almost do like I'm gonna make this step size, and then I'm gonna do this. And for left, it's just gonna be negative. And let's make it when it hits the edge, it changes the states to go a different direction. And eventually we'll have it choose a random direction out of all 8. But for right now, I'm just going to go left. Yeah. So if the X does hit the edge, else, well, yeah, I guess we would always choose from a random of 5 directions. When we hit a wall, we would choose all 5 of the directions that aren't towards the wall. We would have up and towards the wall, we'd have down and towards the wall, we'd have just straight across and towards the wall. The other 5 directions would be eligible. So here we're going to go self current state. I'm just going to do self state moving left. It's only going to bounce back once. It's going to run across to the right and then hopefully run back across to the left, but then it will just stop here since it's going to always keep setting it to left. Eventually, we'll make it bounce back to the right. Let's see if this works, though. We're running to the right. We're looking good. Yeah, we will definitely do that as well. It will stop and it will do the scratching and the sleeping and all of that stuff. Well, basically, when we change states here, we'll choose from either stopping and doing something versus turning around and going a different direction. We'll probably maybe we'll always stop and scratch the edge and then take off after that. This looks like it's working though, so it did keep us going into state moving left. Yeah, so I think our general class is working out pretty good here. We can essentially just now fill in the rest of these things, and with the rest of the framework that we've kind of set up here, we can just change this high level state here and it will kind of do its own thing. As long as we keep calling update, it will keep moving itself around and doing stuff. So let's go ahead and get rid of this and this. And let's start filling in some more of these things. So sitting, it's not going to move at all. So this one's going to be just 0, 0. Okay, moving up. Let's get our 2 sprites for moving up. Those are going to be these 2, which is should be 16, I believe, because it was 8 here. 8, 9, 10, 11, 12, 13, 14, 15. Yeah, 16 and 17. And this will be 0 in the X minus config step size in the Y. Okay. Moving down, this is going to be 8 and 9. And 0 and positive. Config step size. I think these ones, I'll modify both, but maybe a smaller amount. So if we do X and Y both move by config step size, which is 10 right now, if they both move by 10, the cat will appear to move faster because of the way triangles are, basically. There's probably a much better, more convoluted way to explain it, I'm sure. I know this is a thing that you deal with when you make games. Basically, when you're moving at an angle, by default, you're going to be moving quicker than when you're moving straight up, left, right, or down. And so generally, game engines will add a way to accommodate for that. I forget what they call it, but there's a term for the technique they use to mitigate that, to basically artificially slow the player down some when it's moving at an angle so that it kind of matches the movement speed of the straight ones. Equalize, normalize, something like that maybe. So this part's easy. These are the sprites. Up and right, that's these two here, which is going to be, this was 16, so this is going to be 14 and 15. Yeah, Alt-tab that. Can you Control-tab? I can't Control-tab. I'll try to remember that. 14, 15. So do we want to go by half? There's like a formula. I'm sure it's probably not as simple as half, but maybe half is a good substitute for doing the full math. It probably involves Pythagorean. You need like a squared, b squared, something probably to get the exact right actual speed that we would want. Instead, I'm just going to go up and to the right. So up is, well, x is positive. So we're going to go config step size. I'm just going to divide it by 2 and get an int. And then up is minus config step size. Let's do that. Okay, so let's test this out before we get too much further here. So let's, instead of starting and moving to the right, let's say we're gonna state moving down, which we have implemented now. And then here, else self.current state equals self state moving upright. I think we just filled in, right? Yeah. So now we'll run down and then diagonal up and to the right. Everything works. Ooh. This should be less than equals. We're allowed to go on 0. I guess this should be also. There we go. All right, so we got our down run looking good. Up and to the right. Yeah, I like it. Looks good. It's 400. Yeah, thank you, Seagrover. I didn't know the specifics. It's 140% faster when it's moving at a 45-degree angle, I think, and it would then be the square root of 2, which is like e, or I think that's a constant. Maybe I think there's a constant for that. Maybe of sum of sides, sum probably of sides. Yeah. Oh, hey, I didn't watch it when it happened, but we actually ran up here and then we ended up going left. I actually want to see that. Did it obey the clamp on the top correctly? And then I guess it would look weird because it probably stayed at an angle, but then was moving to the right. Which actually doesn't look, I mean, it looks weird because it should turn to the right, but it's not as bad as it could be, truthfully. It looks pretty weird. Yeah, it looks pretty weird, actually. It did work, though. It got to the edge, and then it turned to the left, and that part looks pretty good, actually. So we have Pythagorean cat right now, making a right triangle, pretty much, with this weird flat part on the end. Okay, so I think that looks pretty good. The speed that it was running on the diagonal, I think, was pretty good. So I think let's go ahead and fill in the rest of these. So up left, it's these two, which is, these were 16, 17, so these are going to be 18 and 19. and 19. And up is, well, left is negative. Config step size, and up is also negative. Maybe copy this. Guess the problem is, though, we don't have this one. Let's just fill this in and then go back and so down and left is here. So this was 16, which makes this 24, which makes these two 22 and 23. Control tab. 22, 23. Left is minus and down is positive. Down and right, these are here. 8, 9, 10, 10, 11. Yeah, 10 and 11. Right is positive, and down is also positive. Okay. That should work for us. Let's start with down and right. I don't think I'm gonna test everything here. But let's just go here, state. We'll start with down and right. It's pretty good. And I don't know what we're set up to do here. I guess it's going to change to up and right. Yeah. Actually, it looks pretty good, the way it bounced there. Okay. Yeah. Maybe keep the kitten within a centered square. X is 80 to 400. Not sure what you mean. Keep it within a centered square. So, like, keep it away from the edges of the screen, you mean? Keep it further towards the center? Diagonals are the same. Then the diagonals are the same. I'm not sure I understand what you mean. So we should make some states that are not moving. So it bounces at the corner. Basically make it take larger steps in the X than in the Y, so that the angle would go from corner to corner. Maybe this is what you mean, but I'm not I'm still not 100% sure, sorry. But if we did, like, if the X step was a little bit bigger than the Y step, whatever the ratio of the width versus the height of the screen, if the X was bigger by that ratio, then the angle would match it up with this corner. Make the X range equal to the Y range. Yeah. I think maybe we're thinking the same thing, or a similar thing, at least with the same outcome. I think I want to keep them square, though. I think I like keeping them square so that it could go here, and then eventually it will if the diagonals hit exactly into the corners on the rectangle screen, well, for one thing, right now this code could run on different size screens. But I guess you could also pass it, right? We have a way to pass the display size, which is fine. I don't think I want it to hit the corners, though. I think I want it to hit before the corner. That way, when it bounces and chooses a new direction, it will kind of like... It will make it a... It will go to more different places on the screen. If we hit the corners exactly, and then make a random choice to either go from the corner up or left or up and left, then we really only have like 3 target places. We're going to go down, you know, if we start with that direction, we're going to go down here, and then we're either going to go right back to this corner, right back to this corner, or right back to this corner. If we stop partway, we kind of like could bounce here, and then like eventually go up and come the other way, and it would change. Like we wouldn't hit the exact corners as frequently. If we lined up that ratio perfectly, I feel like we'd always be stopping in a corner. I kind of like the idea of stopping randomly along the edge. It's not perfectly random. There would be a few set spots really based on the size of the display, but let's do a scratching. Scratching left. One thing is we will need to have some kind of logic for like how long does it stay in a particular state. So we're changing states based on hitting the edge of the wall. But for this, we're stationary. We're not going to be moving. I mean, we'll be animating, but not moving. So with one like this, we need to have some logic that says run this animation for either X amount of seconds or X amount of iterations through the animation sprites, and then change to a new state after that. We'll worry about that here in a minute. So first I'm going to declare it. So I guess we have IDs that are incremental, right? I mean, I could, but I really shouldn't just stick this in the middle here. Keep incrementing. So this would be 9. I don't know if we actually need the ID anymore, actually. Maybe we could get away without it. I'm not sure. Scratching left. So this is these two, which would be 24. So this would be 32, which makes these 30 and 31. And this will be 0 because we don't actually take any movement. So we're getting close to really needing to make some logic about how it decides where to go next. But I am gonna, I think, piggyback off of this stuff one more time here by saying if self.x is not equal to 0, then move left, else self current state self state scratching left. I already make. Oh, okay, I made them all. I see. Okay, so actually I already had this. Okay, we started this. Okay, back up here. We actually can do this. bounce up and to the right for now. That's going to bounce us back to the left, and then when we get here, we should go to scratching. One thing we'll probably want is... Ooh, it didn't work. X, I guess, is not quite 0. It's probably 10, I guess. So we got one that was 285. 5 is what we're on, okay. So let's say if it's less than this, but really we want greater than. If it is less than that, then it will go to scratching left. Maybe make it faster or make it not bounce around as much while we're testing it here. Yeah, okay. So I think we're scratching now. The thing is, though, it is a little tough to see the scratching because the scratch marks are black. And our background is currently black. Do we want a white background? Do we want to put the blue background back? That would be kind of funny. Yeah, I think I do want to put the blue back for now. Okay, I'm going to put the blue back. So what color blue is this? 00AEF0. I'm going to go... Okay, I'm going to make a background group. What is the smallest common multiple of 320 and 240? So 10, 20, 32 by 24, both divide by 10. They divide by 12? No. 16? 16's pretty good. Let's do that. So scale 16. Background bitmap equals a new bitmap. Don't know. I think is it XY first and then number of colors? Yeah. Width, height, number of colors. So width and height are 20, 15, because that's what we divided by here. Well, that's what our division told us, 20 and 15. Basically, we're making a small bitmap and then scaling it to fit the whole screen. That way we can save some memory on the background. So this, and then number of colors, we just need 1. Yeah, okay. And we need to make a tile grid. With the background bitmap and I think we can leave everything else default, honestly. We need to make a palette. Palette, 1 color, background palette, only color is background color. Pixel shader, background palette. Okay, background group and tile grid and main group pinned background group. I think that should work. Be close if not. Yeah, okay. That's a nice trick, using groups to scale your background so that you can save some memory. This way we have a bitmap that's only 20 by 15 in memory. Whereas like we could have made this 320 by 240 and just had every pixel be the blue or whatever, right? But this saves us a little bit. And I think that looks pretty good with the scratching now. So we can actually see the little scratch marks. I will say the left and right ones don't look as prominent as the up and down ones. You can see the multiple scratch marks on the up and down ones, but it does look pretty good, I think. We're getting pretty close here. We need to still fill in a few more of these. Yeah, thank you. It's kind of fun to like sit down and kind of start from scratch and build something like this. I kind of aim for higher level project stuff a lot more than I do simple animation. And this is almost like a component of a project more than a project in and of itself, but kind of fun. I like sitting down to kind of really build something up from just the display IO scratch type stuff, right? Starting with tile grids and groups and building on top. So what are our indexes here? Scratching right, these are going to be, this was 16, this was 24, so 26 and 27 we're looking at here. 26 and 27. Movement again is 0. All of these will be movement 0. then we'll have to come up with some logic for how it decides what it's going to do next. This is 24 and 25. I do think I am maybe going to head out before too long, though. I probably won't wrap 100% of this thing up on the stream here today. So 24, 25, 26, 27, 28, and 29 for this one. 9, and then this is still zeros. All right, so the behavior won't change because I didn't modify how it chooses. So I think let's just brainstorm a little bit about the actual logic, how we want it to decide what to do next. And I think I'll do that and then probably call it a day afterwards. So I think let's just, do we want to just make a comment and start kind of dumping ideas? Okay, so I think I think we should alternate between moving states and non-moving states. So if we were just moving in any one of the 8 directions and we hit a wall, or we decide that we want to stop for a different reason, maybe eventually we could stop somewhere randomly in the middle, which would also increase the chances that the cat ends up in a different location, make it appear more random. So if we were moving, then our next state we want to go to is going to be a scratching or a sitting or the yawning, sleeping state. Something that we don't actually move around in. And then after we're done with that stationary state, we're going to choose a new movement state. Hey Keith, hope your day is going well as well, or is going well also, I should say, maybe. Thanks for stopping by. Have you seen our little, I don't know when you joined, if you had a chance to see our little cute cat run here? We'll restart that maybe. Right now we're just kind of hard-coded. It runs like down, and then I think we're still bouncing up this way and then left. And then once we get over here, we'll scratch the left wall. But basically, this is our project for the day, is this little Nico kitty animation where it's going to run around and scratch the sides, and then it's got a sleep animation as well that we're going to work into it. There's our left wall scratch, which I think is looking pretty good. I guess we don't necessarily have to always be on a wall to scratch. I mean, we could just stop in the middle and then scratch any direction we want. Although the wall makes a little more sense, right? Be like the wall is a scratching post. Yeah, I think I like it scratching the wall. Plus, I think maybe Lady Ada mentioned that it scratched the edges. Yeah, I agree totally. This is the, if you're interested in it, this is where this came from. Nico software, which I guess Nico is Japanese for cat, but this was an old school Macintosh thing, or I guess it came around before Macintosh, NEC EC 9801, but Lady Ada had this on Macintosh. And so I was given the quest to kind of port this to Display.io. This is what we've got going so far. So we want to alternate between moving and non-moving. We want to say if we're near an edge, if we are near an edge, then non-moving can be scratching. If we're not near an edge, the non-moving state should be sleeping, I think, or else just sitting. Non-moving state should be sleeping or sitting. And I guess sleeping will be a little different because in the sleeping state, I think we'll go... So I think the sleeping state will go sitting first, and then yawning, and then sleeping and sleeping. And I guess it would loop back and forth between these two a couple of times. And then eventually the cat wakes up. But then we don't really want to loop again after that. Basically want to wake up and then we would choose a new state, probably a moving state. So sleeping is a little different than other states, really. The other states kind of just loop indefinitely. Sleeping has like sprite 1, sprite 2, sprite 3, 4, loop between 3 and 4 a couple of times, and then sprite 5. I don't know if we'll hard code all of that. I guess we could. But sleeping is an animation where once we're through with the animation, then we want to move to a new state. Whereas the moving animations, those just play on repeat until we hit a wall is our current logic. Eventually we may add something else, but yeah, okay. I'm just kind of talking through how some of this stuff will behave. If we're not near an edge, then we'll pick sleeping or sitting. I guess there's also scratching. Really, what is this one? Is this scratching too? So these two are definitely scratching. The leg comes up, scratch in the face, and, you know, it comes down, scratch in the face. So this is like, you know, scratch in my face. This makes sense. What is this one? This almost looks to me like... This almost looks to me like raising your hand in front of your mouth, like to yawn. But I wonder if it's like the start... I wonder if scratching is actually supposed to be part of the sleep animation. Oh, it is. Yeah, it totally is. Because this says here, Nico falling asleep and waking up again. And this one... I mean, this is not necessarily like the be-all, end-all source or whatever. We have some freedom, but we go sitting, scratching, 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 sitting, sleeping, 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 awake. So we actually don't have yawning in this one, which we do have a yawning here. But they did tie together scratching and the sleeping. Licking the paw. Yeah, that's what that one looks like. Yeah, totally. Licking the paw. Good call. I like it. So do we want to go maybe that's all part of sleeping. Maybe sleeping is a more convoluted one. Maybe it goes... Or should we... I think maybe we should separate it. I like the idea of sleeping being on its own. So sleeping goes sitting, yawning, sleep, sleep, loop those, and then wake up eventually, which is the last one there. That's our sleeping animation. And then our scratching, I think, will go sitting, licking paw, and then scratching, scratching. These two loop a couple of times because they like lick their paw and then rub it on their face, right? That's how they clean their face. Yeah. I like that. So lick paw, scratch, scratch. These two loop. Maybe we'll stick another scratch paw again. And then loop one more time with scratch face and then go back to sitting. Something like that. I think so. Yeah. So we'll have sleeping and scratching and sitting, which is our default one. Those are our 3 non-moving states. I'm just going to note these down. Again, I'm just kind of brainstorming here. So this is going to be non-moving states are sleeping, in no particular order. I guess I'll put sitting first, though. Sitting, sleeping, scratching, but I'm gonna call this cleaning. Because we have scratching walls, which are actually also non-moving states. Scratching walls. I'm just gonna put 1, even though there's actually 4, because there's scratch left, right, up, down. That's fine, though. Scratching walls. So those are our non-moving states. And then, of course, our moving states are just moving in each of the 8 directions, right? Which we don't necessarily need to write down, but I'm gonna just, again, because I'm kind of brainstorming here. Moving state, this is just moving in a direction. One of the 8 directions. Put it that way. That way it's clear that it's actually 8 states there. Okay. So I think we'll move for a while, and then we'll stop, and well, no, okay, we'll move for a while. If we hit a wall, then we'll scratch the wall. But we'll also build in a random check to stop, to just like stop and either sleep or clean. So while we're moving, each iteration through the move, maybe we get a random number or whatever, and if our number is a certain one, then we stop and use one of the non-moving, non-scratching states. Specifically, we stop and either sit, sleep, or clean. Or if we make it all the way to the wall, then we stop and scratch the wall. No matter which one of these we did, after we're done, we're choosing a new moving state. And if we were scratching a wall, then we want our new moving state, of course, to be one of the ones opposite the wall. If we were sitting, sleeping, or cleaning, then that implies that we were in the, towards the middle of the screen, probably somewhere. And in that case, we'll just pick a random one of the 8 directions and start moving. I think that is roughly the logic, and I think I've got it in my head now, and so I don't necessarily need to write too much more down. I think I've got this kind of helped me visualize it enough to make that decision. So we're moving while during the time we're moving, we have a chance to stop. If we hit our chance to stop, then we either sit, sleep, or clean. Once we're done with that, we go back to moving and we choose a new direction. Or we don't hit our chance to sit, sleep, or clean, in which case we eventually run into a wall, at which point we scratch the wall, and then we choose a new direction opposite the wall to start moving again. And that's our logic. We just do that over and over. So we're always going to have a chance to stop somewhere in the middle, which means our movement is going to start to appear random. The cat's not always going to it's not going to match an exact rectangle just doing the diagonals or anything like that. It's not going to always be in the same spots. Sometimes it will stop here, sometimes it will stop in the middle, sometimes it will stop closer to the edge. It'll just be a random choice to stop and do the sit, sleep, and clean. And if we don't hit it, then eventually we'll get to a wall, which at that point we'll stop and scratch. I like it. Yep, totally agree. Got us, and that's kind of how we coded it as well. I overrid tile grid, and I've got a lot of these states that kind of hold the behavior data loosely. These are the animation sprites, and then these are the movement steps, like how much it moves and whether it's X or Y. So let's make the sleeping and the cleaning states, and then I think I will probably wrap it up for now after that. So let's go state cleaning. This is going to be 13. These are... I think when we go to clean, I would like to start by sitting. And I think maybe I actually want to do a couple of frames of sitting. So like maybe 2 frames of sitting. Then we lick the paw. Is index 1. Then we lick the paw and put it back down, or go, I think we go straight to scratching the face, basically, or really rubbing the face, I guess, to clean it. We lick the paw, and then we go 1, 2, and then 3. We go back and forth a couple of times on those. So 2, 3, 2, 3, maybe 2, 3, one more. Rub the face 3 times. Want to scratch the paw and do it again? Maybe we do this only 2 times, and then we scratch the paw. I mean, we lick the paw again, and then maybe do it over. Yeah. Sitting, licking the paw, scratching the face, licking the paw again, scratching the face again, and then back to sitting. We do sitting as the last frame again. Now we have a much bigger animation on that one. Movements, 0. State sleeping, 14. Sleeping, I think we should also start with sitting. So I think we go same kind of start here. Sitting, sitting, yawning. Which is what, 4? 0, 1, 2, 3, 4, yep. Yawning, do we want to go maybe yawning and then back to sitting and then back to yawning? Maybe we yawn twice? Kind of fast. Might want 2 frames. We would want 2 frames of yawning as well. Maybe even 3 frames. 1 full second of yawning. That doesn't seem too unreasonable. So sitting, yawning, back to sitting, back to yawning. And then we get into sleeping. Is 5. 5 and 6 loop a couple of times. And then waking up is 7. Maybe we go 7, 2 frames, and then back to sitting. And let's just say... How do we want to test this? Okay, here's what we're gonna do. Start time is time.monotonic. Now is time.monotonic, and now I think I'm gonna go if now greater than, whoops, start time plus. I'm just gonna say after 2 seconds, then I want to change the state. current state equals, let's do sleeping. But you'll have to excuse me, I gotta run to the restroom real fast and then we'll test this. Okay. We should zoom this in. Okay, so we're just gonna go to sleep 2 seconds after we start, I think, and we want to keep doing this, right? We only want to do this once, I think. So one thing is, when we change state, we should put the animation index back to 0 also, so that we start at the beginning of the animation. Otherwise, we could start like in the middle of the sleep animation. Well, not really in the middle. Most likely we'd start on either 0 or 1, since the moving states only have 2 indexes, but we want to always start on 0, I think. Now we'll be walking, we'll change to sleeping, which will set our index back to 0. Only do that once. Okay, yeah, let's give it a try. Oh. Full index is out of range. Did I do the movements wrong? Ah, yeah. Sitting, yawning, yawning again, sleeping, waking up, sitting. There we go. Yeah. I think that's pretty good. So we would wake up, I mean, right now it's just going to keep looping. And what we would do is, well, so we wake up and then we sit. And after we sit, that's when we would essentially go to the next state. So really, I think we want maybe inside of update, this is where we could put some of our logic, like get a random chance and see if we're going to sit and sleep or clean. And then also this is where we could move the clamping logic, like checking if we're near the wall. We could move that maybe up to here inside of update. And then that's where, if we are touching the wall, we would be changing states. So maybe like update, this is our function where the core logic of our state machine lives. This is where we basically decide when to change states and what state to change to. We can get that stuff out of animate, which is where we have some of it right now. And so then also inside of here, we could have that logic for like, if we're at the end of the sleep animation, that's when we know it's time to move to a new moving state. I don't know, maybe this will return something, or we could just check the index, I guess, and compare it to the length. That would tell us if we're at the end of it. Something like that. I think that sounds like a good way to do it. I do want to, before I go though, I also want to test the this cleaning. But I think sleeping looks pretty good. Do cleaning. Yeah, let's stay on licking the foot a little bit longer. I feel like it's super fast. So this, let's just tuck in another one here, maybe. Yeah, that looks more natural. I like it. Yeah. I think it's good. Okay. All right, so we got all of our states are all set up now. The animations appear to be working good for all of them. We got our movement roughly figured out, right? Of course, we definitely still need some work. Like I said, I think what we'll do is kind of move some of this logic that's here now inside of animate over to update, and update will be the function that orchestrates when we change states and what state we change to. Animation will go to just being focused on changing the sprite, basically. And then we basically just build out the logic we discussed up here, put that stuff, put the enforcement of all of that stuff inside of update. It'll be basically, that's basically where we're aiming for, I think. Maybe like stretch goal style, like nice to have. I don't know for sure if I'll do it, but might be kind of fun is maybe if you touch the screen, the cat will move towards where you touched. Because it does, I don't know if I have the one open still. I do here. Because this one does follow the mouse. And then if it catches the mouse, that's where it looks like it's going to start sleeping, maybe. Yeah, there we go. We move the mouse, it'll wake up and follow the mouse some more. So maybe we'll bring that into the touchscreen by saying, if you touch on the screen, then the cat will move towards the spot you touched. It's kind of like a stretch goal. Once we get the rest of the whole logic set up and working, then maybe we'll add that as well, which that gives the user more direct influence over where the cat goes, which is kind of fun. I think I like that idea as well. Yeah, I think we will probably do that touch. Although I think we want it to be, I do think I want it to be fully functional without the touch as well. Like, I want it to be interesting to look at and fun and cute and everything. Like, it should still be able to do everything without touching as well. So that way it could run on a thing without a touchscreen, right? I think we want to be able to do both. So that's kind of like, if you are using a PyPortal or something with a touchscreen, then you get that as a nice little bonus. If not, though, you can still enjoy the cat to its fullest. Ooh. That's a good idea. When you touch, maybe when you touch, it spawns the laser pointer dot. And then the cat runs towards it, and once it gets there, it disappears. Or moves to a different spot or something like that. Laser pointer mode sounds pretty fun. Maybe once the cat gets to the laser pointer, then we just respawn it somewhere else, and then that's where the cat's running to. Instead of choosing a random direction, maybe in that case, well, it's still all random, right? Because it's choosing where the laser goes randomly, but instead of just picking randomly for no reason, it picks randomly, it draws the laser pointer, and then the cat's always trying to follow the laser pointer. So it has, like, thematically, it has a reason to choose that direction. Add bubbles when you put the touchscreen. Nice. Yeah, I do. That's a good idea, Seagrover. I like the laser pointer. Thanks for dropping that one. I think that'll be a cute thing to do as well. And do we have red? No, we have red on the mouth. We have red. Ah, right, there's a heart. I was remembering some other red on this. Little heart. So we'll make a little laser pointer dot maybe. That would be a fun one. Maybe that's where touching. Although I still think it would be nice to have non-touch capable ones still be able to do everything. So maybe it will not be, maybe when you touch, it will place the laser pointer dot, but maybe there will also be some random chance that it places the laser pointer dot somewhere randomly, even if you don't touch. And then it runs towards there, and then once it gets there, it is what to do next. I like that. Okay, I think I'm gonna wrap it up for now. I've been going about 3 hours today, so I'm definitely ready to get up and move around a bit, take a break for a little while. See, we've got a couple of folks on Twitch, so I will maybe find somebody to raid here real quick. Thank you all, everyone who tuned in. Hope this was enjoyable. I will be back next Saturday for sure. Again, I don't know exactly what the plan is going to be on taking over for deep dives. I mentioned that a little bit. I started to mention it again. I don't have anything to commit to right now, but I will probably pick up some amount of streaming. So stay tuned to the Saturday streams for now, and I'm sure I will mention on here whenever I do have a more concrete plan. So let's see, Anthony's on. I think Anthony does weekends a lot, but I did raid Anthony last week. Maybe we'll find somebody new this time. Game Dev Saturday. Making a gym. Game Jam. What's the VT Game Jam? I think I want to do a Game Jam one of these days and focus on a CircuitPython game. A lot of them do like browser-based or Unity or stuff like that. I think it might be fun to take part in a Game Jam and focus on CircuitPython. If anybody else is interested maybe in doing a Game Jam like over a weekend, or I don't know, maybe we do a full week or something. Like we start on one weekend and then we go all the way till the end of the next weekend or something like that. So folks could kind of work on it when they have time. If anyone is interested in doing a Game Jam like that and kind of like sharing our finished product with everybody, let me know if that sounds fun. Maybe I'll try to organize that. This is looking AFK maybe. I'm not seeing a lot of movement and not hearing anything, so maybe we'll pick a different one. 3D character modeling. Oh. Here's something now. Let me, oh, there's music on. Okay. Web development, but this is, we'll pick English maybe. Oh, Dragon Slumber? Multiplayer word game. I think I've watched this person before. They do some interesting stuff. I think we'll raid this one. Like Unity here. So, again, thanks for hanging out, folks. Appreciate all of you. I will see you next week. And again, yeah, just stay tuned. Eventually, I'll figure out what the plan for Fridays is going to be. Yeah, and we'll raid this person. So enjoy Dragon Slumber if this is something that you find interesting. Otherwise, I will catch you next time. I do need to find the right window to raid from, though. I will stall for a few more seconds. Here we go. Raiding, paste this. All right. Here we go. All right. Thanks all. Catch you all next time.